CUA 13 retake. Number 1. The regular polygon has radii and azimuth shown below. Find the measure of each numbered angle. So let's start with the measure of angle 1. Which is right here. All right, so that angle is a central angle, and all around the center, all the way around the center would be 360 degrees. And then we can see that this 360 is broken up into 1, 2, 3, 4, 5, 6, 7, 8 parts. So if we wanted to find the measure of just one of them, we would divide and get 45 degrees. The measure of angle 2 So as you can see here, angle 2 is a central angle as well, but it's half of this entire angle, which would be congruent to angle 1. So we're just going to take that 45 degrees and divide it by 2 since it's half. So the measure of angle 2 is 22.5 degrees. The measure of angle 3, different ways we could do this, but I'm just going to use the triangle sum theorem. So this is a 90-degree angle right here. So we have 90 plus 22.5 plus angle 3 has to equal 180. We already know that 90 and 180, if you were to subtract, you would get 90. So I'm just going to do 90 minus 22.5. And that would give us 67.5. All right, number 2. Find the area of a triangle whose height is, okay, so first of all, it says area of a triangle. So we're going to use that formula, whose height is 5 centimeters and whose base is 8. So we could do PEMDAS if we wanted to, and half of 8 is 4, which means the area is 20 square centimeters. Number 3, find the area of a rhombus with diagonals of 16 and 14 feet. All right, so this diagonal would be 16, this one 14, and we need to find the area. So the area of a rhombus is 1/2 diagonal 1 times diagonal 2, which would be 1/2 14 times 16. Okay, we know half of 14 is just 7. And now we just have to multiply 7 times 16 to get 112. And since this is area, that'll be square feet. Number 4, find the area of a trapezoid whose height is 6 centimeters and whose bases are 8 centimeters and 12 centimeters. So area of a trapezoid would be 1/2 times the height times the sum of the bases. So that'll be 1/2, and the height is 6, and the bases are 8 and 12. So we're going to follow PEMDAS and do parentheses first. And we can see here that 6 times 1/2 is 3. And 3 times 20 is 60. Again, this is area, so that'll be square units, and the units are centimeters. Number 5, find the area. So first, identify what kind of shape this is. Now we're going to find the formula for area. This is a kite, and the area formula is the same as rhombus. So 1/2. And a diagonal is a line segment that goes from one vertex to a non-consecutive or non-adjacent, or yeah, non-consecutive vertex. So this 16 and 20 are your diagonals. All right, if we use PEMDAS, we see here 1/2 of 16 is 8, and 8 times 20 is just 160. There is no unit of measure, so I'm just going to leave it as 160. Number 6, this is not a shape that we have a name for, nor is it a shape that we have a formula for. This is two shapes put together. I see a semicircle, and then I see a trapezoid. So we're going to have to do the area of both. All right, so the area of a circle is pi r squared, so a semicircle will literally just be half of that. 1/2 times pi, and the radius is 12. All right, so if we follow PEMDAS, we need to do this exponent first. So that'll be 144. And then half of 144 is 72. All right, so the area of the semicircle is 72. And now we're going to do the trapezoid. Okay, so that's going to be 1/2 times 24. We'll do parentheses first. That'll give us 50. Half of 24 is 12. And then that'll be 600. All right, so to find the area of the whole thing, we need to add the 72 and the 600. And that'll give us 672 square centimeters for this entire composite figure. Number 7, this is a trapezoid. The whole thing is a trapezoid. A lot of people thought it was a trapezoid with a triangle attached to it. I mean, you could do that technically, but you don't know how long this is because you don't know how long this is, so you can't subtract and get 2. That's not going to work, okay? So the whole thing is a trapezoid, treat it as such. All right, so if we do PEMDAS, we'll do the parentheses first by adding and getting 14 with the 6 and the 8. Now we're going to do just left to right because it's all multiplication from here. So that'll give us 2, and that'll give us 28. Number 8, this is a regular hexagon. I know it doesn't say that, but I'm telling you it is. So the area of a regular hexagon or any regular polygon is 1/2 times the apothem times the perimeter. So the apothem here is unknown. All right, so since this side is 10, I know this side is 5. And since this is a hexagon, that means this is 30 degrees right there. That angle is 30 degrees right there, which means this is a 30, 60, 90 triangle, which means that the apothem is 5 square root of 3. Okay, so that'll be 5 square root of 3. And we got to multiply by the perimeter. So this is 10, and there are 6 sides. So 10 times 6 is 60. All right, I see here, I don't have to go in order when multiplying, so I'm going to go ahead and take half of 60 because that would be easier than taking half of 5 square root of 3. So that'll be 30. If I take half of 60, right, that's 30. And then 30 times 5 is 150. All right, so you can leave your answer like that, or you can type that in your calculator. And that would give you, okay, so either one of these would be acceptable answers. Number 9. Again, we have a regular polygon. I know it doesn't say so, but I'm telling you it is. Sorry. Da, 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 da. So we have 1/2 times the apothem times the perimeter. The apothem is 15. The perimeter is 10 square root of 3. Just kidding. The side length is 10 square root of 3, but there are 6 sides. So that's 60 square root of 3. All right, so just like I did last time, I see this 1/2 in the 60. I can get that pretty easily. That's just 30. So I can do 30 square root of 3 times the 15. Oh, whatever, it doesn't matter. I'll put 15 right there. And I can multiply this and this, and that'll give me 450 square root of 3. All right, so you can leave your answer like that, or, and again, this is not again, but this is meters squared. Or we could change it to decimal form, square meters. All right, number 10. So we have this regular triangle. Now, this is an apothem, so we could use this formula. Some of you are like, oh, it's a triangle. I can use this formula. Hold on, stylus isn't working. Okay, so we could do either one, but if you use this one, you have to figure out the height of the triangle. And no, it's not 12. This is not 6. No, no, no. Um, so yeah, yeah. All these sides are equal though. Again, I didn't tell you, sorry. I'm telling you now. So yeah, that's what you would have to do. You could figure that out because this line right here is a median. And if you remember when we did points of concurrency or centers of triangles, if this is 6, this would have to be double that. That would have to be 12, and then the whole thing would be 18. All right, so the base, this is just 12 square root of 3 because it's an equilateral triangle, so all the sides are the same. So 12 square root of 3, and then the height would be 18, right? Because 6 plus 12 is 18. So you could do that, and then that would give you, let's see, 1/2 of 12 is 6, and you can just multiply that by 18. Was that 108 times the square root of 3? Okay. If we do it this way, this will be, so now I'm using the regular polygon formula. So the apothem was 6. The perimeter is going to be this times 3. So that's 36 square root of 3. All right, I know that's going to give me a 3. And 3 times 36 is just, 108. So either way, we get the same thing. All right, and if you want to put that in decimal form, just multiply it out in your calculator, and that'll give you 187.06 square centimeters. 11. All right, this is another shape we don't have a formula for, but we can break it down. So I'll break it down to these two rectangles. Um, this one is 11 by 7. So 11 times 7 equals 77. This one, let's see, we got to figure out how long that is. Well, we know that the whole thing, that whole line right here is 11 because it matches with that one. So if this part is 5, we can subtract 5 from 11 to get 6. Oh, this is a square. How convenient. So that means this is 36 because 6 times 6 equals 36. And now we just can add them together, really. And that's going to give us 113. And this is feet. So that's square feet. Number 12, again, we don't have a name for this whole shape, so we need to break it down into shapes that we do recognize. So we have this triangle up top, and we can easily find the area of a triangle by doing 1/2 base times height. This is 16, so this is also 16, which means this is 32, which makes sense because that's 32. All right, so 1/2 of 32 is 16, so that's 16 times 12, which is 192 for the triangle. And now we're going to do the rectangle at the bottom. So this rectangle down here is just length times width. So 32 times 15. That'll give us 480. And then we just got to add those together. All right, number 13, find the area of the shaded region. So for this one, we got area of the square, which is just 20 squared, which is 400. Then we got area of the circle, which is pi radius squared, so that's 100 pi. And to find the area of the shaded region, we have to subtract. So 400 minus 100 pi, and that'll give us 85.84, and that's square inches. All right, next, let's see, we got, this is just a parallelogram, and this whole thing is a parallelogram, but this is a trapezoid. And again, I'm sorry, it doesn't explicitly state that. That's on me. That's on me. I'm so sorry. But just take my word for it for this. So I'm just going to do the area of a trapezoid because this is a trapezoid. Okay? Save yourself some work if you can. All right, so that's going to be 1/2 times the height, which is 12, times the bases, which is 30 plus. Let's figure this out real quick. This whole thing is 30. So if we take away 9, that's going to be what, 21? All right, 1/2 of 12 is 6. 30 plus 21 is 51. All right, so that's 306. All right, now if you wanted to be extra and do it the long way, you could do the area of the parallelogram, and that would be base times height. And then you could do the area of the triangle. That would be 1/2 base times height. And then you would subtract. So 360 minus 54 still gives you 306. Okay. Number 15, Jose cut the corner off a large rectangular board. What remained is the shaded portion. What's the area of the shaded portion? So we want the area of all of this. And guess what? Hold on. Oops. All right, so now we're going to find the area of the square. I'm not the square, I'm sorry. The rectangle. All right, so that's going to be 12 times 10. All right, now we got the area of the triangle, the unshaded triangle, and that would be 1/2 base. Okay, let's figure out the base. That was 12, and if we take off 4, 12 minus 4 is 8. So the base is 8, and then the height, well, the whole thing over here is 10, right? Because that's 10. If we take 4 away from 10, that's 6. All right, so that's 4 times 6, that's 24. And now we're going to subtract, and that'll give us 96 square feet. Number 17, what's the probability in a percent that a randomly chosen point will lie in the unshaded. So this would be the unshaded region right there. Okay, so the area of the the area of the square, I'll put square, is 10 squared, which is 100. The area of the rectangle, because this is a rectangle, or sorry, this is a rectangle because the sides aren't equal. That's going to be 4 times 5, which is 20. And to get the probability, sorry, to get the area, no, yeah, we already got the area because we need the unshaded. So to get the probability of unshaded, we're going to put unshaded area over the whole thing, and that's just 20%. All right, what's the probability that a dart will hit outside of the inscribed circle? So basically shaded. We need the probability of the shaded region. So let's get into it. This is going to be area of the square, sorry, and that's 40 squared, so that's 1600. Area of the circle, the radius is 20, so it's going to be pi 20 squared, so that's 400 pi. We need area of the shaded, so that's going to be 1600 minus 400 pi. All right, so that'll be about 343.3629, blah, blah, blah. Not rounding yet. Don't round to the very end. All right, and to get the probability of the shaded region, you're going to need that number we just did here. And we're going to put that over the area of the whole thing. Do not add the areas together, baby. This is the whole thing. Just put the 1600 as the denominator. All right, so that should give us round about, excuse me, 0.21, which is about 21%. Oh, it says 1 decimal place. Just kidding. 0.2. There you go. All right, if the side of a square were to double in size, what would happen to its area? It would quadruple. I'm not going to explain this now because it's in the next unit. Number 18, how many square feet of carpet would be needed to cover the bedroom floor? Let's go ahead and break it down. All right, so we got 6 times 15, which is 90. So 6 times 15, that's how I got that. And then here, this is 16. I can tell because this is 6, this is 10. 6 plus 10 is 16. And then we got to multiply it by, let's see, this is 15. This whole thing is 20. So if we subtract that 15, we get 5. So that's 80. And now we got to add these two together. And that should give us 170. And that's square millimeters. What? Why on earth would you measure a bedroom in millimeters? Sorry. Okay, moving on. Number 19, what's the sum of the measure of the interior angles? So that would be 180 times n minus 2. So 180 times hexagon is 6 minus 2. 6 minus 2 is just 4. So what is 180 times 4? That's 720 degrees. Try number 20 on your own.